Hello everyone. In this video, we are going to look at the concept of potential gradient. To look at the concept of potential gradient, we will arrive at this relation where electric field intensity is represented as negative potential gradient. We are going to arrive at this relation from the known expression for potential which we have discussed in the previous videos. When we look at the expression for potential in terms of electric field intensity, we have represented if there are 2 points A and B, and if you are trying to move a charged particle from A to B, in that case, potential difference between A and B can be represented as minus line integration E dot dl, where the lower limit being the initial position and the upper limit being the final position of the charged particle. In terms of general line integration, we can represent this as voltage equals to minus line integration E dot dl. Now from this expression, we are going to arrive at the relation which is shown here, that is electric field intensity is negative potential gradient. This relation is true for electrostatics, means static electric fields. So we can write the differential form of this equation by differentiating. So differentiation of this left hand side will give dV and the right hand side has integral. If we differentiate that, integral will be cancelled out, which will give the expression which is differential potential dV equals minus E dot dl. Now what we are going to do is we are going to take this dot product between E and dl and write this in terms of angle between the two vectors. If I consider E vector and dl vector are through an angle of theta between the two, then this dot product can be written in terms of cosine of that angle theta. So we can represent this E dot dl as magnitude of E multiplied with dl multiplied with cos of angle between the two. Now from this we can rearrange the terms and arrive at this expression which is negative potential gradient. So this dV by dl we are going to write, that is dV by dl can be written as minus E into cos theta. Now we are going to look at how this negative sign is going to affect the relation between E vector and V. So this minus E cos theta, this significance we are going to look at from this graphical representation. Now we are going to consider when will this expression reach maximum value. That is dV by dl maximum will be attained for an angle of pi. Means if theta equals to pi, cos pi is minus 1. In that case, E and dl are through 180 degrees. Means both are opposite in direction. Means if E is increasing in this particular direction, then dl is opposite to that. We will learn the significance of what is this opposite direction and what is the direction of E with respect to dV. We will discuss that shortly. But from this expression, let us now consider the maximum value of dV by dl is E, which occurs at an angle of pi, means E and dl are opposite in direction. Now we can write the maximum value of this expression, which is E maximum is minus dV by dl. And we can write the direction of E and dV by dl are opposite to each other. So we can write in the vector form as E vector is minus dV by dl AL cap, where this AL cap indicates the direction of variation of V. So if I consider this dl, then the direction of AL cap is in this direction, which indicates variation of V with respect to that particular distance. Or we can say electric field is in the direction of decreasing potential. If I say E vector and dl vector are opposite to each other, this dl indicates variation of V with respect to distance. So these two are opposite, which means if E is increasing, then dV by dl is going to be decreasing. Or you can say electric field is in the direction of decreasing potential. Minus dV by dl indicates potential variation with respect to L, which is negative, means decrease of potential with respect to distance. Minus dV by dl talks about decrease of potential with respect to distance. Thereby, we can also say electric field is in the direction of decreasing potential with respect to distance. Now, this dV by dl AL cap, this talks about variation of v with respect to distance, or you can say this is the slope of v. In vector terms, the slope of v in three-dimensional system, we call it as gradient. So thereby this expression for E can be written as minus gradient of potential V or minus del V. We can also say electric field is in the direction of decreasing potential. So you can understand the direction of electric field is in the direction of decreasing potential, which is, for example, if we take two plates, one plate is at positive 120 volt, another plate is at positive 60 volts. In this case, the electric field between the plates will be directed from higher potential to lower potential. That is given by this minus del V. V is changing with respect to distance, and that change is negative gradient, means minus dV by dL is indicating the electric field intensity vector. That is, electric field is in the direction of decreasing potential. So we can write the mathematical form of this E equals to minus del V in all the three coordinate systems. In rectangular system, del V expression can be given as this, which means variation of V with respect to X in the corresponding X direction, variation of V with respect to Y in Y direction, variation of V with respect to Z in Z direction, where V is a function of X, Y, Z in rectangular system. In cylindrical system, the potential function can be given in terms of a function of rho phi z, and the corresponding gradient formula is given. And similarly, for spherical system, E equals to minus del V or grad V formula can be written in terms of V, which is a function of r theta phi in spherical system. Thank you for watching the video.